Welcome to Module 2, where we'll take a look at machine learning. So in this module, we're going to look at what machine learning is, get an introduction to that. We'll take a look at different types of machine learning. So we'll look at regression, classification, and clustering. And then we'll turn our attention to Azure machine learning. And we'll look at what Azure machine learning is and how we can use it to perform automated machine learning and use the Azure Machine Learning Designer to drag and drop and create machine learning models without writing any code. So in this first lesson, we're going to cover some basic principles of machine learning. Now, it's important to understand these principles, largely to give you a context for the services that we're going to look at later. So there's some basic fundamental concepts you need to understand. There's a little bit of math involved, and you might find that a little intimidating if it's been a while since you did some math. Don't worry too much about that. The math itself is fairly intuitive. Once we go through the examples, you'll see what's going on. So let's start by defining what machine learning is. Now, machine learning is a technique that we can use to create predictive models based on relationships in data. Well, what does that mean? Well, let's look at an example. Suppose a botanist collects some samples of flowers. Now, each sample has some features, such as measurements of the petals, the stems, other details. And the botanist can provide a label for the flower using its species name based on those features. So we have various different varieties of flower here. Now that sample data is then processed using an algorithm that tries to find a relationship between the features, those measurements of the flower, and the label, the species. The result of that algorithm is a machine learning model. And now that we have that machine learning model, it's learned the relationship between the features and the label, so we can use it to predict the species of a flower based on its features. Now, one of the most common machine learning scenarios is called regression. And you use regression when you want to predict a numeric value, like a price or a sales total or some other numerical measure. So let's take a look at an example to get an idea of how it works. So in this example, imagine that we're a bicycle rental company and we want to predict the number of bicycle rentals on a given day based on the weather conditions. So we'll start with some historical data about cycle rentals. And in a simple example, we'll restrict this to just the temperature and the number of rentals per day. In reality, there would be more factors to consider. Now, the number of rentals is the label that we're going to try to predict, and we're going to try and use the daily temperature to predict that. Generally, we refer to the features as X and the label as Y. So what we're going to do here is try and figure out a function that we can apply to X, in other words, the daily temperature, that's our feature, to get the value Y, the number of rentals, which is our label. And that function will be the basis of the model that we can use to predict Y for any given value of X. Now, when we find a function, we'll want to validate it with some data for the days where we already know the number of rentals so that we can see how well it predicts. So we'll split the data into a subset that we'll use for training and another subset that we'll hold back and use for validation. Now, to find an appropriate function, let's plot the X and Y values so that we can visualize the relationship between them. And looking at the plot, you can see there's a trend in which the higher temperatures tend to correlate with more rentals. And in fact, we can fit this line between the plotted points that more or less describes this correlation. And we can use this line to work out a calculation that produces Y from X. Now, this ability to use a line like this is technically called linear regression, which sounds a bit complicated, but let's look at the basic principles of that and see how it works, and hopefully you'll find that it's actually fairly intuitive. Now, the point where the line intercepts the y-axis is around 35. And the slope of the line is such that for every 1 unit of x that we go along to the right, it goes up around 1.5 units of y. So that gives us a function that is basically the intercept, 35, plus 1.5 times x. So we start at 35, and then when we want to find the value on the line, for each value of x that we go along, we go up 1.5 times. Now we can test that function with the validation data that we held back. And here are the values that we get from that function for the temperatures on those days. Now, because this is a prediction of y rather than the original actual y value, we write it with a little hat on top of it and we call it y hat. Now let's plot the actual values from the validation data along the line from which the predicted values were calculated. Now we can see how well the model predicts by measuring the difference between the predicted values and the actual values that we know to be true. And that tells us the amount of error that we have in the model. There are various ways that we can calculate that error, and we can generate some common metrics from that we can use to evaluate the regression model. So this is just a simple example that describes the general concepts and the process for training and evaluating a regression model. In the real world, the training algorithm would need to fit multiple features, multiple x values into the regression function, but the basic principle remains the same. You start with data that contains features and labels. You use some of the data to train a regression model that uses an algorithm to find the relationship between x that predicts y. And then you evaluate the trained model using the validation data that you held back, and if you're happy with the level of error that you have after that, you can then use that model to infer unknown label values in new cases. Now, regression that we've just seen is a form of supervised machine learning. In other words, it relies on us having some data with known label values that we can fit to a model, and then we can apply that to new data for which we don't have the label values. Now, there's another type of supervised machine learning model, and that's called classification. And again, there's a little bit of math involved, and in particular this time we're going to think about some probability. But again, don't worry too much about the details. Just remember that when we're dealing with probabilities, a probability is always a value between 0 and 1, where 1 means, yes, this is definitely true, 100% certainty, and 0 means, no, this is definitely false, definitely not true. So just as with regression, we'll start with some data that includes features and labels. In this case, the features are medical measurements that might be taken during a health checkup, such as weight, height, blood pressure, and so on. And this time the label isn't a numeric value, but it's an indicator of whether a patient is diabetic, in which case the label has a value of 1, or not, in which case it's 0. Now the label indicates to which class the patient belongs, diabetic or non-diabetic. Once again, we'll split that data into subsets for training and validation. And we'll take the training values and we'll apply an algorithm that fits them to a function so that the y value it produces is between 0 and 1, like this. Now, since the value can be anywhere between 0 and 1, a threshold value is used to determine the cutoff point where we consider it a 0 or a 1. So in this case, all patients with features producing a value greater than 0.5 are diabetic, and those with values below that threshold are not. Now the function we've fitted to the data is an example of a logistic function. And you can think of the value as representing the probability that the class is 1. In other words, in this case, the probability that the patient is diabetic. Having determined a function that fits our features, a model is produced, and we can use the validation we held back to test it. And here's the results of applying that logistic model to our validation features. Now the function returns the probability that the class is 1, or positive, as a value between 0 and 1. And since there's only 2 possible classes, and there's a 100% probability that the patient is either diabetic or not, then the probability that the class is 0, or negative, is just 1 minus the probability that it's positive. The class with the highest probability is the predicted value for y. Let's look at the first validation case. And in this case, the predicted class label is 0 and the actual label is also 0. So the model got it right. It's a true negative. The second case results in a prediction of 1 for an actual value of 1. So again, it's correct, and this time it's a true positive. The third case, well, the prediction is 1, but the actual label is 0. So our model got this one wrong. It's a false positive. And the fourth one, well, again, this time it's wrong, but this time it's a false negative. Now, when we want to evaluate this model overall and see how well it's performing, we can tabulate these results into a format called a confusion matrix. In a real scenario, we'd actually have many more data points than this, so we would have something that probably looks a bit more like this. And if we apply a heat map to that, intensifying the color of the cells in the matrix to reflect the values, you can start to see that there's a pattern developing. There's a dark diagonal line from the top left to the bottom right, indicating that the model got more predictions right than wrong, because those cells are the ones where the predicted and the actual values are the same. So from the values in this confusion matrix, there are a whole bunch of other metrics that we can calculate that we can use to measure the performance of a classification model. So regression and classification are both forms of supervised machine learning. Let's take a look at a form of unsupervised machine learning, and this is called clustering. Now, suppose we have some observations of flowers, and we've noted the height and the number of petals for each flower sample that we've collected. And what we want to do is we want to group flowers that are similar together, but we don't have any sort of label. We don't have the species or any kind of label that we can use to train a model. So instead, we think of the feature values and we think of them as being coordinates on which we can plot some sample data points. So in this case, we've got two features. We've got the height and we've got the number of petals. So we get a nice two-dimensional grid. In reality, you would have more features and we would have to think about it in multiple dimensions, but it's easier to visualize it as a two-dimensional grid here. Now we need to decide how many clusters we want to group these observations into. And we usually refer to this value as k. And we then just simply assign k points at random locations on the grid. So we'll use a k value of 3. We're going to create 3 different clusters, and we'll just randomly assign these values onto the grid. Now each of those points is going to be the centroid, in other words the center point of a cluster. And what we do is we assign the sample points that are nearest to each centroid to its cluster. So if we fill that in, we've now got some flowers assigned to the centroid that's nearest them. Now the next step is we move the centroids into the middle of the cluster so that it's at the mean point, the mean distance between all of the data points in its cluster, in this case between all of the flowers in its cluster. And because we've moved the centroids, some of the sample points might now be nearer a different centroid than the one that they were originally allocated to, so we reallocate the samples to their nearest centroid. And then we just simply repeat that process until all of the clusters are stable, or we reach a predetermined number of iterations that we've said is the maximum. In this case, the clusters soon stabilize as well-separated groups of related flowers. So this clustering technique, where we used k centroids, k was the number of centroids, and we moved them to the mean distance between the data points, is not surprisingly known as k-means clustering. Alright, so now that we've got some basic principles of machine learning under our belt, let's take a look at Azure Machine Learning. So what is Azure Machine Learning? Well, it's a cloud-based platform for machine learning, and to use it, you need to have a Microsoft Azure subscription. And in that subscription, you're going to create something called an Azure Machine Learning workspace. And that's a logical container for all of the resources that you need to manage machine learning projects. Now, one of the most important resources you're going to create is compute. And you're going to use that compute to run machine learning workloads in the cloud instead of running them on your local computer. You also need to manage the data that you need to build machine learning solutions. You've got data that you train models with, you'll need somewhere to keep that, and again, we can store that in the cloud in our workspace. Now we'll use that data and we'll use it to run experiments on our compute resources, and we'll keep track of those experiments and the metrics and the outputs that we get from them. And often those experiments are actually used to train machine learning models. So we can take the model, which is the output from the experiment, and we can register that and we can manage that in our workspace. And when we're ready to use those models in applications, we can publish them as services that can be accessed over HTTP connections. Now, one of the capabilities that we have in Azure Machine Learning is automated machine learning. And that provides the easiest way to train a machine learning model for regression or classification or forecasting, which is really just regression with a time series element to it. There's a visual interface that we can use, and all we need to do is to supply the training data that we want to train the model with, select the required model type, and Azure Machine Learning goes off and does the rest. Now, if automated machine learning doesn't give us the results we need, we can actually take a little bit more control over building the model by using a visual drag and drop interface called Designer. Now, on the left-hand side, you can see the overall kind of process that we use this. We start by creating something called a training pipeline, and that will train and evaluate the model. And then from that, we create an inference pipeline, which represents how that model will be used when we have new data. And then we deploy that inference pipeline as a service so that our applications can consume that service and use it. Now, these pipelines that we're creating, you can see the graphic on the right there. They're made up of multiple modules that we connect together into a kind of workflow, into a data flow. So in this case, the pipeline starts with a data set, and that's our patient data for our diabetes diagnosis that we saw earlier on. And before training, the data is usually pre-processed to clean it up and make it more suitable for modeling. And there's a number of different cleanup steps that we might perform. In this case, we're doing something called normalization. In other words, we're taking all those different values like height and weight and blood pressure and so on, and we are scaling them all to the same numeric scale. So we haven't got lots of very big values and very small values. They're all on the same scale. Then we split the data. So we have a split data module that will randomly split that data set into training and validation subsets. That's a very common step when we have a supervised machine learning model. And we connect the training subset to a train model module. That's where we actually do the training. And training, if you remember, is fitting the data to a function using an algorithm. And in this case, the function that we're creating needs to produce a diagnosis of diabetic or non-diabetic. So it's a classification function. So we go and find out a classification algorithm, and in this case, we will use a two-class logistic regression algorithm. There are multiple algorithms that you can use. That just happens to be the one we've chosen this time. After training, we use a score model module, and that will take the validation data, the data that we held back, and it will run that through the model that we've trained so that we can compare the predicted values to the actual label values that we know from the original data. Then we can use an evaluate model to calculate the metrics that help us determine if the model is any good. So in this case, it's a classification model. So our evaluate model will calculate the accuracy and produce that confusion matrix of true positives and false positives and true negatives and false negatives. So let's actually take a quick look at using Azure Machine Learning Designer. Now, I'm in the Azure portal and I have deployed this machine learning workspace here. And if I go open that, I can see the details of that, and there's a link to try this Azure Machine Learning Studio environment, which is a web portal for managing my Azure Machine Learning resources. And I've opened that up in another tab. Here it is here. So I'm in Azure Machine Learning Studio, and there are a number of different resources that I can see in this location that I can manage. So for a start, I've got some compute resources. We'll just hide some of these messages that we don't need. And in that compute, I've got a thing called a compute instance, which is a virtual machine that I can use as a workstation just to run some code on and experiment with. I have a compute cluster, which is a scalable set of compute resources that will scale up on demand when I need it. So if I need to do a lot of work with a lot of data, I can use this cluster to do that at scale. And I also have an inference cluster, which I'm going to use to deploy a model as a service. Once I've trained a model, I'll deploy it to a cluster so that I can then consume it from client applications. Now, I could attach additional compute. I haven't got any additional attached compute in this case, but if I already had an HD Insight cluster or a Databricks cluster or some specialized form of compute in my Azure environment, I could attach that there. But I'm going to do most of my work with these three: inference, compute, and compute instance. So what else have I got in here? Well, I've got some data. I've got a few data sets in here, and the important one here is this diabetes data set that I've got in here. That's a tabular data set, and if I explore that, you can see that I've got some data in here. This is just the top 10,000 rows, but I've got data in here that has some sort of patient ID, the number of pregnancies, the plasma glucose level, the diastolic blood pressure, and so on, a whole bunch of different kind of medical measurements that you might get if you were undergoing some sort of testing in a clinic. And then an indication at the end here as to whether this person is diabetic or not. So a 0 or a 1 for that classification of whether or not this person is diabetic. And what I'm going to do with this data is I've got a designer environment here. And on that designer tab, I can create a pipeline here. And I've actually already got one here. I've got my diabetes training here. And if I bring that up, you can see what I've done here. I've got a bunch of modules. And I dragged from the dataset section here, I dragged my diabetes data set out. and I place that on here. And then I've got a whole bunch of other modules. You can see all the different categories of module that you can use. There's loads of these things, but I've dragged a few out just to kind of see how they work. So I've got my normalized data module out here, and if I take a look at that and look at the parameters here, this is going to do min-max normalization, so it's going to scale all the data between the minimum and maximum values. And the columns it's going to affect, if I just do this edit column, I've selected these individual columns from the data set, so these are the ones that it's going to normalize. And then I can just close that. And so we follow this data flow through these different modules. I then split the data so that some of the data is going to be used to train the model and some's held back to validate the model. And to train the model, I've got this train model module here, and it's going to train it to predict the diabetic column, which is that 1 or 0, that classification of whether this person is diabetic or not. And so because that's a classification model, I've used a classification algorithm. In this case, I've used the 2-class logistic regression algorithm here, and there are some parameters there. I've just used the defaults for that to train that model. Now, once that's trained the model, it's going to try and fit the training data to the model so that we predict the classification, the 1 or the 0. And I'm going to take the data that I held back, the validation data, where I already know the class of the patient, whether or not they're diabetic, and I'm going to score that data against the model. So if I actually go and have a look at that, I can see in the outputs here, I can actually view the outputs that I get when I ran that. So here are the various columns in here. And if I scroll along to the end here, here's the diabetic column, which either has a 1 or a 0. And here's the scored label. So that's what was predicted by the model. And if I scroll down there, I can see that there's a 0 and a 0 and a 1 and a 1. So I got these ones right. This next one it got wrong. It's actually a 0, but it predicted a 1. And then it got the next one right. So there's some data in there that shows me what's been predicted against what was the actual value. And I also get the probability score. So remember that this is the probability of it being a 1. So when it's above 0.5, like this one here, it predicts a 1. And when it's below 0.5, it predicts a 0. So that's what we're getting from there. And then I can take those results and I can compare the predicted value with the actual value, and I can evaluate that model. So if I take a look at this evaluation here, again, I can view the output of that. And I get a whole bunch of metrics that I can use to evaluate that model. I want to scroll down and just focus on this confusion matrix, which shows me all of the times that I predicted 1 and it was 1, or I predicted 1 and it was 0, and so on. So I've got my true positives, my false positives, my false negatives, and my true negatives all in here. And I can see a little bit of a diagonal trend there. So I'm getting more right than I'm getting wrong with this model. And there's a whole bunch of other metrics that get generated based on what's in the confusion matrix that are fairly standard metrics for evaluating a classification model. So assuming I'm happy with the results of that model, what I can then do is I can take this pipeline here that is used to train my data, train my model, and I can create from that an inference pipeline. And I've actually done that. I've used this create inference and created a real-time inferencing pipeline. And if I go and have a look at that, what that looks like is over here. And again, it's another pipeline. So again, it's some of these modules here. We'll just zoom out a little bit so we can see it a bit more clearly. And I made a few changes to this. Instead of using the actual diabetic data source, I've entered some data manually. And the reason I've done that, if we just look at the data that I've entered into there, and we should be able just to go and edit that. The original data, of course, had the diabetes value in it. And I needed that when I was training and I wanted to evaluate, but now I'm building a pipeline that's going to be used for inferencing new data where I don't know whether the person is diabetic or not. So I've created a data set in here just that has 3 patients, and it has a whole bunch of different fields up to the age, but it doesn't have the diabetic diagnosis in here. We don't know the class of this user. So this is just some data that I'm going to use to run through my pipeline to predict some new values. Other things I've done, I removed the evaluate. We don't need to evaluate this because we're actually using this for real with new data. And I've added in this Python script here. Now, you don't need to worry too much about the details of the code, but what this is doing is just reducing the results that come out so that we only include the patient ID. We'll actually just show you the code here. The patient ID, the scored labels, which we're going to call diabetes prediction, and these scored probabilities, which we'll just call probability. So instead of returning all of the fields that go through the pipeline, we're just going to return those 3 fields. So we get the patient ID and whether or not we're predicting this person's diabetic and what the probability is that we think that they are. So that's been run. You can see the little green ticks. I've run that on my compute, and that's worked successfully. So having built that inferencing pipeline and tested it to see that it runs, I was then able to deploy that. And I deployed that as an endpoint. So if we're going to have a look at our endpoints, it's this one here, it's predict diabetes. And if I take a look at that endpoint, I've got a whole bunch of information about it, but the important stuff that I need here is on this consume tab, where I have a REST endpoint. So that's the address that my client application needs to send the data to in order to have the prediction generated. And we have a key that we use to authenticate. So not anybody can call this, you have to have the appropriate authentication key. So my client application needs both of these bits of information. It needs the REST endpoint and it needs either the primary or the secondary key. We can use either. So I've taken that information and I have built a very simple little client just with some basic Python code. Here it is here. I would just edit that code in line, and the code here I can see I need my endpoint and my key, so I'll go and get those. We'll just we'll open up another tab here, and we need the REST endpoint, so we'll just copy that and put that in here, and we need the key, so we'll just copy that and put that into my code as well. We'll just put that here. We'll just hide this so we can see what's going on a little bit better. So I've got my endpoint and my key, and then there's some basic code that passes in an input, and the input is just some details about a patient. So the patient ID, the number of pregnancies, the plasma glucose, and so on. And that's going to get passed into the REST endpoint where my service has been published. It's going to use my inferencing pipeline to take that data and submit it to my model, and then it's going to return the results, and the results are going to be the patient ID, the prediction, and the probability. So we'll display those results when they come back. So let's go and run that code. And what I get back is the patient ID, the prediction of 1, so in this case we're predicting this patient is diabetic, and the probability that gave us that prediction. So in this case we're saying there's a 70% probability that this patient is diabetic. So now it's your turn to have a go with using Azure Machine Learning, and the instructions are here. We're going to use one of the modules on Microsoft Learn, and it contains some instructions for you to create an Azure Machine Learning workspace, create some compute targets and explore some data, and then train a machine learning model and deploy that model as a service. Now the lab is in this module on Microsoft Learn, and you can see that there's a number of different units in the lab. We can actually skip the introduction and the what is machine learning because we've already covered that on the slides, and go straight to the create an Azure Machine Learning workspace. So starting from here, we're going to work through the lab. Now I'll just show you what's involved in that. So here I am in the Azure portal, and the first thing I'm going to do is I'm going to create an Azure Machine Learning workspace. So we'll create a resource, search for machine learning, and we get this machine learning option. We'll go ahead and click create. We need to give our workspace a name, so I'm going to call this Learn AML. I need to choose the Azure subscription that I want to create it in. I've only got the one, so I'm going to choose that subscription, and I'm going to choose the resource group I want to create this in, and I'm going to create a new resource group in this case, which I'll just call AML resources. I can choose where I want to deploy this. I'll choose the region nearest to me, and then the workspace edition I want to create. And the important thing here is we have to choose the enterprise edition because the visual tools that we're going to use aren't available in the basic edition. So we'll review and create that. That all looks fine to me. Go ahead and click create, and off that goes and creates that workspace. And after a little while, that gets deployed, and I can see that I've got the link to go to that resource. So if I go to that, I'm in my machine learning, Azure Machine Learning Workspace resource here. I can see the information about all of that. And there's a link here to use a tool called Azure Machine Learning Studio, which is the interface where we're most likely to want to work with it. So I'll go and launch that. That opens up in a new tab. And I'll get this welcome message. I'll just cancel out of the tour. And this is the interface where I can manage all of my Azure Machine Learning resources. Now, some of those resources I'm going to need are going to include my compute and my data. So let's start off with some compute. We'll go and manage our compute. I got a few little warnings and messages here, which I can just close and ignore. And there are 4 different types of compute that you might manage. And the first we're going to worry about is a thing called a compute instance, which is really just a workstation, a virtual machine that runs in my Azure Machine Learning Workspace here. And I need to give that a globally unique name. So I'm going to give that just my name, VM. Hopefully nobody else has got one with that name. It's going to be created in the region where my workspace is. I've got the choice of using CPU or GPU processing. I'm going to go with CPU, and I can choose what size of virtual machine I want to make. There's a whole bunch of options there that I can choose. I'm just going to go with the default size here. I'm not going to worry about any of these advanced settings. I'll just go ahead and click create, and that is going to go and create this cloud-based virtual machine that I can use for working with my code. I can use that as a development workstation effectively. Now, in most cases, that might be all I need, but because I want to run an experiment that is going to try lots and lots of different algorithms, I want to have some scalable compute that's going to do things at a large amount of scale. So as well as my compute instance, I'm going to create a compute cluster. And if I go to my compute cluster, this is going to create a multi-node cluster that will scale automatically depending on how much work it needs to do. So we'll go ahead and create a new resource there. I'm just going to call this AML cluster. Again, we can use a CPU. This is going to be dedicated priority, so it's not going to be preempted by anybody else. I am going to change the size of it a little bit. So rather than a standard DS3, I am going to use a standard DS2, which is just slightly smaller. Save myself a little bit there. And I'm going to tell it that I want a minimum of 2 nodes and a maximum of 2 nodes. So it's always going to spin up 2 nodes effectively. I could change that to 0 so that it doesn't cost me anything until I use it, but it'll take a little while to start the nodes up if I do that. So we'll go ahead with that. We'll let it run for 120 seconds before it scales down, and we'll ignore the advanced settings. Go ahead and create that cluster. So that's going to go off and be provisioned in the background there. It's creating that cluster. I can check in my compute instance. Again, we'll just get rid of these messages, and it's still creating that. It'll take a little while to create. So while I'm waiting for that, we'll move on to the next thing, which is to think about my data. Now, the data I'm going to use, I'm going to go and manage a data set here. If you lose the titles down here, you can just click that little menu there to expand out and see where everything is. And what I want to do is I want to create a data set here. So we'll go to data sets. Again, we'll just put that in. And I'm going to create a data set, and I'm going to create I've got a choice of a bunch of different locations. In this case, the data I need is on the web. So I'm going to create it from a website location. And that location is https aka.ms bike rentals. So we're looking at the scenario where I'm trying to predict the number of bikes that would be rented in a given day based on the weather and the conditions and that type of thing. So I'll give this data set a name. I'll call mine bike rentals. And it's going to be tabular. It's a table of data. I happen to know that already. I could give it a description. So bike rental data. And we'll move on to the next step. So it's gone and parsed that data, and I can actually see, if I look way down here, I'll see a preview of the data. And you can see that it's got column 1, column 2, and then the first row actually has what look like the column headers. So we need to change this setting here. Column headers, we will use the headers from the first file. And now my preview looks a bit more sensible. We've got the day, the month, the year, the season, and so on. And right at the end, the very last column is the number of rentals that happened on that day. So we'll leave the rest of those settings and we'll just move forward to the next step. And this gives me the schema of that data. I can see that I've got the various different columns and what are the data types of those columns that have been detected. I'm pretty happy with all of that, so we'll just move on to the next step. We will confirm the details and go ahead and create that data set. So my data set has been created successfully. I can see the message up here. And if I go and have a look at that data set, we'll just open it up. And I can see some details there about it. And I could explore that data set and get a chance to see some of the data. So I can see the days or the day of the month. So that goes all the way up to 31 and then starts again. And then the month is obviously the month of the year. So January, February, the year. This is fairly old data. The seasons, these are coded seasons. So 1 for spring, 1 for winter rather, 2 for spring, 3 for summer, 4 for fall. Whether or not this day is a holiday, what day of the week it is. So we've got the number of days of the weeks, whether that's a working day or not. So is it a weekend or a day that people are working? There's some various weather data as well. There's a specific encoding of the weather, the temperature, the air temperature, the humidity, the wind speed, and then the number of rentals that were made on that day. So we've got some data now that lets us see for any given day, given its weather conditions and its kind of seasonal information, how many rentals we actually made on that day, how many bikes were rented. Okay, so now I've got my data set. We'll just go and check on the compute, which is down here. And I can see that my virtual machine, my compute instance, is now running. And my compute cluster has been provisioned. It's got 2 nodes ready for me to use. So I've now got my data and my compute, and I'm ready to start training a machine learning model. So to do that, again, we'll just have a look at the menu over here. We have this automated ML option here. So we'll go to automated ML. And what I can do in here is I can go and create an auto ML training run based on my data that will find the best algorithm for training my model out of that data and give me a good predictive model. So we'll create a new auto ML run, and we're going to base that on a data set. So we need to select our data set, choose our bike rentals data set, and we need to configure the run. So the run is actually something called an experiment. So we need to give this an experiment. So we'll call it auto train bikes. And we need to select what is the column that we want to train this model to predict. So we'll have a look at the columns that we have, and the one that we want is the rentals. So that's what we're going to try and predict. Now to run this experiment, we need to run this on a training cluster. So we'll select that cluster that we created earlier on, ML cluster, and then we're ready to move to the next step. Now the next thing we have to decide is what type of model is it that we want to train. Now in this case, we're trying to predict the number of rentals, so that's a numeric value, and that means that it's a regression model. So we'll select regression, and we'll have some additional configuration settings for regression. So we're first of all going to look at the configuration. The primary metric is the way that we measure how closely the model predicts compared to the true values that we already know in the training data. So there are a number of different metrics that we can use. We're going to use something called the normalized root mean square error, which is a fairly common metric that involves measuring the distance between the predicted values and the actual values. We could have it generate an explanation for the best model. We'll leave that just now, but what we could do with that is we could have it explain which of the features are most influential on the prediction that gets made. So which of those features are causing it to predict whatever it predicts. There are loads of algorithms for regression. So we can see a whole bunch of them here. Now what we could do if we had a lot of time, we could just let it go ahead and try every single algorithm that's available. we're just going to limit this. We're going to remove some of these from here, just so that we can speed things up a little bit. So we'll leave random forest and light GBM. Those are two pretty good algorithms for us to use, and we'll ignore the others. But like I say, if you have a lot of time, you could just let it try them all and see which one performs best. So we'll save those settings. And then the other thing we want to think about is featureization. So we've got the features of our model, those different bits of information about the day of the week and the weather. Particularly those kind of weather values are in different scales. So we will probably want to have those normalized so they're all on the same scale. And we also want to deal with things like missing values. So if there's anything missing, we want to impute a value in there. So maybe just use the mean value or use a 0 or something like that. And we also want to deal with things like columns where really they aren't very predictive. There's a high cardinality, as we call it. There's a lot of different values and it's not really going to be predictive. So we'll enable featureization, and that means that without us having to worry about the details of all of that stuff, Azure Machine Learning will automatically apply featureization to improve the prediction of the model. So that's everything in place. We're ready to go. We'll just click Finish now. And that will go and create our automated machine learning run. And that run will start. It'll take a little while to spin up the compute. And we'll see this run status change as it starts to run the experiment. So we'll just give that a few minutes to get going. After a while, the status changes to running. And once it started running, we can start looking at the models that the experiment is generating. So it's trying various different algorithms. We can see the algorithms here, and it's also doing some featureization there. So it's scaling the data here as well. And it is taking a sample of the data, running an experiment to train that, and we can see the status of that. So we'll just wait for a few of these to get trained. And after I've got a few models trained, I can go ahead and cancel the run. I could leave it running and it will try all sorts of different combinations, but it'll take a little while. So I'm just going to cancel that run. We'll see yes to canceling it. And once it's cancelled, if I go and have a look at the details for the experiment for this run, I get this best model summary. So I can see the algorithm name. In this case, the name consists of the algorithm. In this case, it was a random forest algorithm, and the scalar that was used to normalize the data, so a standard scalar. And I can see the normalized root mean square error. That was the metric that we were optimizing for, so I can see that there. And if I actually click on that algorithm, I'll get some details about it. I get the same information here. I could view all of the other metrics that I could use to evaluate this model. So explained variance is the amount of difference in the predicted value against the real value that is explained by the model. So that's 0.8. It's a value between 0 and 1. We want that to be quite high. The mean absolute error is just the average distance between the predicted and actual values. The mean absolute percentage error is the same thing as a percentage. There's various different values. The one that we're concerned about really is this normalized root mean square error, which is the mean error squared, and then we take the root of that. So we've got this model that's trained. We can actually look at some visualizations of that model to help us evaluate how well it did. And the first visualization we want to look at is this predicted versus true chart. And I can see the ideal line would be this green line going up here, where I've got the true value along here. It correlates exactly with the predicted value up here. What we're seeing here is the average predicted value is the blue line, and the light blue is the kind of edges of that, the area around that, if you like, the threshold. And I can see that mostly that pretty much ties with my ideal line. So I'm getting a pretty good value for my predicted versus true. And I've got this bin count here along that scale, the number of predictions that we had in each. So there's more rentals down at this end of the scale than up here. So on most days, there's between kind of 38.9 and just over 1,000 rentals. And then on very few days, we get these high numbers of rentals. And if I scroll a little further down, I get this residual histogram. Residual is a fancy word that data scientists use to mean the error, the amount of difference that's left over between what's predicted and what was actually the real value in the data that we had. And I can see that these residuals are clustered around 0. The most residuals are quite small, so the error actually is a fairly small value. We don't get really very many big errors, many predictions that are really far out. There's much fewer of those than there are ones that are kind of clustered around 0, and that again is a good sign. It means that although we're getting some error, the errors tend to be fairly small. So we've got our model here, and again I can just look at the details of that and get a summary of all of that. And what I might want to do with that model, since I'm pretty happy with it, it seems to perform pretty well, is deploy that as a service for applications to use when I want to predict the number of rentals in a given day. So we'll click deploy, and I get the option to send out this this deployment, and we're just going to call it predict rentals. I'll give it a good name, and the description just to help people understand what this does. So it's a service to predict bike rentals. The compute type I'm going to deploy it to, there's two different types of compute target that I could use here. There's AKS, which is Azure Kubernetes Service, and I would use that if I were deploying this into production. I want a nice, highly scalable, highly secure service. Because I'm just testing, I'm going to use an Azure Container Instance, an ACI. So it's just a simpler way to deploy, and I don't need to go and create any explicit compute for that. So we'll create ACI. And I will enable authentication just so that we can test it securely, and we have to authenticate against the service to use it. So let's go ahead and deploy that, and it will start deploying the model. And I get a message here that says the deployment started successfully. So it's not deployed yet, it's just started deploying. If I scroll down, I can actually see the deploy status down here, and the deployment is running. So it's in the process of deploying at this point. So we'll just wait for that to actually be deployed. And when it's deployed, we'll get this status of successful. So we're ready to go and use that endpoint. And I could either just click the endpoint here, or in this endpoints section over here, I can find it. So there's my predict rentals endpoint. And if I go and have a look at that endpoint, I can see some information about it. And then on this consume tab, if I were writing an application to consume it, this is the information that I'm going to need. I'm going to need the endpoint address, this REST endpoint HTTP address here, and I need the authentication key. So if I authenticate using a key, I can use either of these, the primary or the secondary key, to authenticate with that. Now that's going to be useful because I'm going to want to try and use an application now to test this out. So to do that, I'm just going to open up a new tab. Here it is here. And I'm going to, in this tab, I'm going to go to the Notebooks tab. So I've now got two tabs open, both of them pointing to my Azure Machine Learning Studio. This one points to my endpoint where I've got the information I need. And on this one, I've got my notebooks. And I'm going to create a new notebook. And I will just give it a name of test rentals or something like that. And the type of notebook is a Python notebook. We're going to use some Python code to test this. So off that goes and creates this new notebook. And I get some little messages appearing that I can just go in and close. And I need to run this on my Azure AML workspace here. And we'll go ahead and edit this in line. So now we're ready to go and edit that notebook. I'm ready to start putting in some code here. Now you might be thinking, hey, I don't know what code to write. That's okay. If we go back to our exercise in Microsoft Learn, and I go to the appropriate bit here. So we're on the deploy as a service. We actually have the code that we need here. So we can just go and copy that code. And then I can come back to here and I can paste in that code ready for me to run. We'll just close this pane here and make things a bit easier for us. Now you see there's a couple of variables here that we need to replace, the endpoint and the key, which is what we've got here. So we'll go and copy that endpoint and we'll just replace that value here. And we will go and copy the key as well. And we'll place that in here. So now I've got my endpoint and my key. I've got some code. Don't worry too much about the details of this. All we're doing is we're generating 5 days worth of weather data. So we've got 5 days, 1, 2, 3, 4, 5. And each day there's the day of the week, the month, the year, the various weather features, all of the features that we had that we need to predict the number of rentals. So we're going to take all of that, we're going to set up a header for an HTTP request, and we're going to send that HTTP request to our endpoint where our service is, and we'll get back a result, and that result will include the predictions of the number of rentals for that given day. So we'll go ahead and run that code. And I get back my prediction. So on day 1, the predicted rentals is 564, day 2, it's 466, and so on. So I've got all these different predictions coming back. So my model that I trained using automated machine learning is predicting rentals. We're pretty happy with the evaluation metrics that we looked at earlier on, that it's predicting reasonably accurately. And I've now deployed that model as a service, and my applications can use that endpoint for that service to pass it in some details about some days and get back the predicted number of rentals for those days. So in this module, we covered what machine learning is, and we looked at different types of machine learning like regression, classification, clustering. And then we turned our attention to Azure Machine Learning. We learned a little bit about what Azure Machine Learning is and creating an Azure Machine Learning workspace and the different types of resource that we can have there. And then we looked at automated machine learning for training models just from our data. And we talked about the Azure Machine Learning Designer, which gives us that drag and drop visual interface where we can create a pipeline that trains a model, and then we can deploy that pipeline as a service and consume that from client applications. Now there's more that you can learn. There are some hands-on activities that we haven't had time to do in the class, but if you go and have a look on Microsoft Learn at the no-code machine learning path, then there are some modules there that you can use to explore a little further. Now the Create No-Code Predictive Models with Azure Machine Learning path is 4 modules long. Now we've already done the lab on building automated machine learning, so you've seen most of that, but it's worth going and reading through the introduction and the what is machine learning topics. There's a module on creating a regression model using Azure Machine Learning Designer, which gives you an opportunity to take a look at building a regression model using the drag and drop modules in Designer, creating a training pipeline, an inferencing pipeline, and then deploying that. Then there's the module on doing the same thing but with a classification model, so building out that diabetes classification model that we talked about. And then finally there's a module on creating a clustering model where it's not supervised learning. We don't have a known label in the training data. We just simply create a clustering model that separates the data based on similarities in its features. So it's certainly worth going and spending some time working through these modules on Microsoft Learn to dig deeper into some of the things we've looked at in this module.